In the spring of 1882, a party of visitors in good coats and good hats stood at the foot of Shakespeare Cliff, 2 miles west of Dover, and waited their turn to be lowered into a hole in the ground. The cage took them down a shaft about 160 feet deep, through chalk, past the drip of groundwater, into a gallery lit by electric lamps. Electric light was still a novelty in most of Britain in 1882. Down here, it was the working standard, strung along the roof because the men needed to see what they were doing and because Sir Edward Watkin understood the value of an impression. At the bottom, the visitors were given champagne. Then they were taken out along a bore 7 feet across, cut clean and round through grey chalk, until they had gone the better part of a mile from the shaft. Somewhere on that walk, they passed under the low water mark. After that, the roof above their heads was no longer Kent, it was the English Channel. At the far end stood the machine, some 30 feet of iron lying in the tunnel, with a head of steel cutters that turned about twice a minute and advanced 5/16 of an inch with every revolution. It ran on compressed air, which meant it did not poison the air the miners breathed. It worked more or less all day. On a good week, it made 100 yards. Within a few months of that spring, the machine stopped turning. The pumps were kept going for a while, and then they were not. The shafts were covered over. The tunnel that Britain had already begun driving under the sea towards Calais filled with still water, and it stayed that way while the country argued about it for the next 100 years. This is the story of the Channel Tunnel that Victorian Britain started, got a long way into, and then abandoned. The money was there, the chalk was cutting cleanly, and the engineering, by every account of the time, was going well. It stopped because a large number of serious people became convinced that a tunnel to France was the fastest way to lose the country, and they said so loudly enough to be heard. The tunnel that finally opened in 1994 crosses almost exactly the ground the Victorians were surveying. It runs through the same band of chalk marl they had already identified as the right layer to bore. It comes ashore near the same cliff, and when the modern tunnellers went looking, they found the Victorian bore still there, still round, waiting in the dark, about half a mile out under the water. 112 years passed between the day the boring machines stopped and the day the first passenger train ran. That is the gap this video is about. Where it came from, who closed it, and what it cost. The idea was older than Watkin and older than the railways, which brings us to Edward Watkin. He was born in Salford in 1819, and by the 1870s, he was chairman of 3 railway companies at once, and one of the most restless men in British business. His ambition ran in a straight line on a map, a railway from Manchester to Paris, under his control the whole way, with the Channel crossed rather than sailed. By 1880, he was in a position to start digging. The French started first. From 1877, there were shafts down at Sangatte, west of Calais, one of them over 300 feet deep. On the English side, an early trial at St. Margaret's Bay, east of Dover, was abandoned when it flooded. Then, in 1880, the work moved to the place that mattered. In the summer and autumn of that year, a shaft went down at Abbott's Cliff, on the coast between Folkestone and Dover, on railway land. It was the shallower of the two, around 74 feet. From the bottom, a gallery was driven, roughly parallel with the shoreline, 10 feet or so above the high water mark, as a proving run. Welsh miners did the digging, brought in because they were the best hard rock men available, and because the Southeastern could get them. Trials with the boring machine began there in October of 1880. By February of 1881, the operation had shifted westward to Shakespeare Cliff, closer to the shortest crossing, and a second shaft went down about 155 feet through the chalk. That became the working face. From there, the bore turned out to sea and started running. The machine deserves its own minute. Colonel Frederick Beaumont was a Royal Engineer and a Member of Parliament, and he had been thinking about mechanical tunnelling since the 1860s. His design was refined, and by several accounts substantially improved, by another army officer, Captain Thomas English of Dartford in Kent, who took out his own patent in 1880. Which of them deserves the greater share of the credit has been argued over for a century and a half. The machine is usually called the Beaumont English, and that is the fairest name for it. The performance was extraordinary for the period. The claim made at the time was that it could cut nearly half a mile a month. What it actually achieved, in real chalk, with real stoppages, was around 100 yards a week. Do the arithmetic on that, and you get about 3 miles a year, and a full crossing of some 22 miles underwater, or 30 including the approaches, starts to look like a decade of steady work rather than a fantasy. Watkin talked about having a pilot tunnel through by 1886. By the end of 1882, the Abbott's Cliff heading had run to somewhere near 900 yards, and the Shakespeare Cliff heading had passed 2,000 yards. Figures vary between sources by 100 yards or so, depending on whether you count to the day work stopped or to the final measurement, and I would not fight anybody over the exact number. What is not in dispute is that a little over a mile of tunnel had been driven from the English shore, most of it out under the seabed, and that on the French side at Sangatte, another mile and a half or so had been driven towards England, using the same kind of machine. Add both sides together, and by the spring of 1883, the two countries had cut something in the region of 3,800 yards of tunnel towards each other. Down at the far end of the English bore, one of the Welsh miners, a man recorded as William Sharp, cut his name into the chalk wall. It is the kind of detail that survives when the accounts and the share prospectuses do not. And then the country decided it did not want it. The turn came fast, and it came from the army. Lieutenant General Sir Garnet Wolseley was, in 1882, the most famous soldier in Britain. He had made his name in Canada, in Africa, in Burma. The phrase, "all Sir Garnet," meaning everything in good order, was in ordinary speech because of him. He held senior staff office at the War Office. When he wrote a memorandum, it was read. He wrote one about the tunnel, and its argument was not complicated. A tunnel gives an enemy a road. It does not matter how many gates and floodable chambers and demolition charges you build into the English end, because in the moment that matters, someone has to decide to use them. Wolseley's scenario was a surprise seizure of the Dover end by a few thousand men, some of them arriving as ordinary passengers on a night when Britain was not expecting trouble, followed by 20,000 more coming through the hole before anyone in London had agreed what was happening. Take the exit, hold it for a day, and the Channel, the thing that had kept the country from being invaded since 1668, would be finished as a defence. He put it in a line that stuck. A tunnel, he said, would be a constant inducement to the unscrupulous foreigner to make war. In February of 1882, extracts from his memorandum reached the public through a magazine called The 19th Century, and the campaign began in earnest. A petition against the tunnel was got up within weeks. What is beyond argument is the shape of the thing. In the space of a few months, opposition to the tunnel became a respectable opinion held by clergymen, generals, scientists, and men of letters, and support for it became the position of a railway chairman with an obvious financial interest. That is a very hard hand to play, and Watkin played it badly. He was combative when he needed to be reassuring. He treated objections as obstacles to be gone round, rather than fears to be answered. He kept boring. Gladstone, the Prime Minister, was personally sympathetic to the tunnel. He had been down it. He thought the fears overblown and said so in private. He was also running a liberal government with Ireland and Egypt on his desk, and no appetite whatever for a fight against the entire senior officer corps over a railway scheme. So he did what governments do. He sent it to a committee. While the committee was being arranged, the Board of Trade found a way to stop the digging. The instrument was Section 77 of the South Eastern Railway Act of 1881, a clause which forbade the company from tunnelling beyond the low water mark without specific authority. Watkin's position had always been that the experimental works were permitted, that nobody could object to a trial bore, and that the question of a full tunnel could be settled later. The Board of Trade took the view that he had already gone past the line, and in the summer of 1882, it moved to make him stop. The order to suspend boring at Dover is dated in the first week of July 1882. The record of when the machines actually stopped is a little softer, and work seems to have run on into August while the lawyers argued. There was a court process. There was an inspection of the workings by board officials, granted by court order. And the board's own engineers subsequently had to admit that some of their calculations about the works had been wrong. None of that changed the outcome. There is no great scene to describe at the end. That is generally how these things go. Somebody shut off the compressed air and the cutting head stopped turning, and the noise that had filled that tunnel for the better part of 2 years was replaced by the sound of water moving in chalk. The men walked back a mile to the shaft with their tools. The Beaumont English machine was left where it stood, at the face, pointing at France. For a while, the pumps kept the workings dry, because everyone assumed this was a delay of months. The Select Committee sat through 1883. It heard the engineers and it heard the generals. And when it reported, it split 6-4 against the scheme. That was enough. On the 24th of July, 1883, Watkins' Channel Tunnel Experimental Works Bill was withdrawn from the House of Commons. The workings themselves went quiet in the way that abandoned things do. Above ground, the argument carried on without the tunnel. Then came the Second World War, and for 6 years, the invasion argument stopped being theoretical. And it is not hard to see why nobody in Britain wanted to discuss a permanent road to occupied France between 1940 and 1945. What finally killed the military objection was the aeroplane. By the mid-1950s, with bombers and paratroops and the beginnings of missiles, the Channel had stopped being the wall it had been in Wolseley's day, and the chiefs of staff conceded the point. The defence case against the tunnel was formally dropped. Britain had spent 70 years refusing to build the thing on grounds that the 20th century had already overtaken. Wolseley himself had been dead since 1913. The argument he started outlived him by 40 years, and was ended, in the end, by a weapon that made his whole premise irrelevant. So it happened twice, once in 1882 and once in 1975. Britain began digging a tunnel to France and then stopped. And both times the reason came from Westminster rather than from the chalk. It is what happened during that 1970s attempt that gives this story its ending. When the modern engineers reopened the Shakespeare Cliff shaft and pumped out the water, they went looking for the Victorian heading. About 40 metres out from the bottom of the shaft, they found it. The Beaumont English bore was still there, 7 feet across, still round, still unlined. The tool mark still legible on the chalk after 90 years underwater. They dewatered a long stretch of it, put in steel ribs and timber where the ground had moved, and walked out along it for the better part of half a mile, before sealing it off with a concrete bulkhead a little over 800 metres from the shaft, because beyond that point it was not worth the risk. Think about that for a moment. Men in 1970s hard hats, standing in a hole cut by a compressed air machine in 1882, under the sea, in a tunnel that had spent its entire existence full of water and had not fallen in. The chalk marl held. Thomas de Gamont, diving with pig fat on his head to bring up samples, had been right about the seam. Beaumont and English had been right about the method. The Victorians had been right about all of it, except the politics. The tunnel opened on the 6th of May 1994. It cost around £4.5 billion. It runs 31.5 miles, 23 of them underwater, through the same chalk marl the Victorians had identified, coming ashore within sight of the ground where the first machine stopped. So what did the delay cost? The honest answer is that nobody can put a number on it, and anyone who gives you one is guessing. But some things can be said plainly. A pilot tunnel through by the late 1880s would have been a working link between Britain and the continent for the whole of the period in which Britain's trade with Europe was at its most intense. It would have existed through 2 world wars, which is precisely the objection and precisely the thing that makes it impossible to model. Perhaps Wolsey's ghost gets the last word in 1940. Perhaps a tunnel with demolition chambers, blown in the summer of that year, would have been a footnote. We do not know, and pretending otherwise is not history. What can be said is narrower and, to my mind, more interesting. The Victorians had the geology right. They had the machine right, 90 years before anybody built a better one. They had chosen the correct alignment, the correct stratum, and the correct landfall. And the modern project confirmed every one of those decisions by making the same choices. The one thing the 1880s could not solve was whether an island wanted to stop being an island. That question took 112 years, and in the end, it was not answered by engineers. Watkin got the direction of travel right and the timing wrong, which is the standard fate of that kind of man. He was not a modest figure, he was not always straight with Parliament, and his habit of digging, while the argument was still going on, did his own cause enormous damage. But when the first Eurostar ran from London to Paris, it ran under the sea because he had proved it could be done, and it came ashore about where he said it would. If you stand on the beach below Shakespeare Cliff today, with the trains from Dover running past behind you and the ferries out in the strait, you are standing on a shelf partly made of chalk that came out of that first tunnel. Somewhere under your feet and out beyond the low water mark, the last of the Victorian bore is still down there in the dark, full of water, with the marks of the cutters on the walls and a Welsh miner's name scratched into the chalk. Trains pass within yards of it several times an hour, carrying people to France. Nobody on board those trains ever knows. And I would like to know something else. Every part of this country has one. The cutting that stops at a field, the abutment in a wood with nothing on either side, the shaft capped with concrete behind somebody's garden wall. Some project that was started properly, with money and men and machines, and then abandoned by people in a room a long way away. What is the one near you? Leave it below and tell me what stopped it, because someone always knows.